Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 22 and today we will again solve a problem based on graph data structure and the level of this question is going to be medium. The name of this question is course scheduler. You will get this question link in description and you can also download this Excel sheet from description. Now, without wasting much time, let's see our question on LeetCode. So here we are on LeetCode and the question says there are a total of num courses. So let's assume this num courses variable as n for now. So there are a total of n courses you have to take labeled from 0 to n minus 1. Okay. You are given an array prerequisites where prerequisites of I is equal to a of I and b of I indicates that you must take course B of I first if you want to take course AI. Okay. So for example, if we are having a pair 0 and 1, then it indicates that to take course number 0, firstly you have to take course 1, right? It means that if you are having a pair A of I and B of I, so to take this course A of I first, you have to complete this course B of I. Okay. And we have to return true if we can finish all the courses, else we have to return false. So firstly, let's analyze this problem by taking some examples and then we'll think of how we can solve this problem. Let's start with the first example where number of courses are equal to 4. It means that the courses are listed from 0 to 4 minus 1, which is 3. Okay. So in total, we have these 4 courses. And here we also have a prerequisites array or vector. But here you can clearly see that this prerequisite is empty. It means that we do not have any compulsion or we do not have any prerequisite to complete any course. So what I can do, firstly, I can complete this course 3, then I can complete this course 0, then I can complete course 1, and then probably I can complete this course 3, right? So this can be one order of completing the courses, okay? Because we do not have any prerequisite, so I can complete courses in any particular order. I can also complete courses in this order, right? So in any order, I can complete the courses. And the question says if it is possible to complete all the courses, then we have to return true, okay? So therefore, we will return true for this particular test case. Now, let's take this example number 2. Okay. So here the number of courses are equal to 4. It means that the courses are listed from 0 to 3. Okay. And these are our courses. And we also have some prerequisites. Okay. So if I take this prerequisite, then what it says? It says that to complete this course number 1, right? To complete or to take this course number 1, firstly, you have to complete course 0, right? So I can say that firstly, I need to complete this course 0. And once I have completed this course number 0, then only I can go to course number 1, right? This is what this first requisite is saying. Okay. So now if we take this second prerequisite, then this second prerequisite says that if you want to take this course number 2, then before taking this course 2, you have to complete this course 1. Okay. So firstly, I have to complete this course 1 and then only I can take my course number 2. Okay. And if I take this particular prerequisite, then this prerequisite is saying that to take this course number 3, right? If you want to take this course number 3, firstly you have to take or you have to complete the course number 2, right? So firstly I need to complete this course number 2, and once this course is completed, then only I can take this course number 3. So this is the order of courses, okay, as per our prerequisites. So you can clearly see that I am able to complete this course number 0, course number 1, course number 2, and course number 3. It means that I am able to complete all the courses. And if it is possible to complete all the courses, then we have to return true. Okay. So for this example test case, we will return true because it is possible to complete all the courses, right? Now let's take this particular sample test case. So here the number of courses are equal to 2. It means that the courses are listed from 0 to 2 minus 1, which is 1. Okay. So we have only 2 courses, right? And here we have some prerequisites. So if we are considering the first prerequisite, then it says that to complete this course number 1 or to take this course number 1, firstly you have to complete the course 0. So firstly I need to complete this course number 0, then only I will be able to go to course number 1. Okay. And if I consider this second prerequisite, then this second prerequisite is saying that to take this course number 0, firstly you have to complete the course number 1. So it is something like that. To take course number 0, like if you want to take the course number 0, so firstly you need to complete the course number 1, right? So this will be the ordering. Okay, and if I just combine both of them, then the relation would look something like this. Okay, so this will be our relation. Okay, and if I just explain you, then see, as per our first prerequisite, if I want to complete, or if I want to go to course number 1, then firstly I need to complete the course 0. Okay, so let's say I'm standing here at the course 0. Okay, if I'm standing here at the course 0, then my second prerequisite says that if you want to take this course number 0, then firstly you should complete course 1. Okay, so if I want to complete course 0, then the prerequisite says that go and complete course number 1. Okay, so now I'm standing here at the course number 1. Okay, and here the first prerequisite says that if you want to complete the course number 1, then firstly you have to complete the course number 0. So again, from this course number 1, I'll go to course number 0. Okay, so now I'm standing here at the course number 0. But again, as per our second prerequisite, it says that if you want to take this course number 0, firstly you have to complete the course number 1. So from this course 0, again I have to go to the course 1, right? So here you can clearly see that there is a loop, right? There is a loop. Whenever I'm trying to complete my course 0, it says go and complete course 1, and if I'm trying to complete my course 1, it says that go and complete course 0. So overall there is a loop present, and if there is a loop present, then it is not possible to complete the courses. Okay, and if it is not possible to complete the courses, then we have to return false. Okay, so this is our question. I hope now the question is clear to you. Now if we try to think of how we can solve this problem, then this problem is based on graph data structure. How I got to know that this is based on graph data structure? The very simple answer is, while explaining you the different sample test cases, I took help of different nodes and I tried to create a link between the different nodes. Okay, so this was your first hint from where you can understand that yes, this is a typical graph question. And in the question it was clearly mentioned that in a pair, if we are having a of I and b of I, and this a of I, it should be completed first in order to take this b of I. Okay, and if you have learned something known as topological sort, then from this particular statement I think you would be able to guess that this is a standard graph and standard topological sort problem. Okay, and whenever we are dealing with the topological sort, we know that there are two ways to do topological sorts. Okay, the very first one is using the DFS, and the second one is using the BFS. Okay, so you can take any one of them, but for this video I'll cover this BFS approach first, and then probably in next video we can think of this DFS approach. Okay, so in one of the examples I have explained you that if there is a cycle into our graph, then it is not possible to complete all the courses, right? Therefore for this question, what we will be doing is we will just detect cycle into our graph, and if there is a cycle, it means that we cannot complete all the courses, so we will return false. If the cycle is not present, it means that we can surely complete all the courses, so we will return true. And we will do topological sort using BFS to detect cycle into our graph. Now topological sort with BFS is also known as Kahn's algorithm. So in any article, in any tutorial, if someone is saying that they are going to use Kahn's algorithm, then don't get confused. This is the exact same thing what we are going to use in this video. Let's take this particular test case. So here the number of courses are equal to 4. Therefore the courses will be from 0 to 3. So in total we will have 4 courses, 0, 1, 2 and 3. Okay, and here we have some prerequisites. So if you are having a prerequisite A and B, so what does it mean? It means that if you want to take this course number A, then firstly you have to complete this course number B, right? So the link will be from B to A, right? Firstly we have to complete course B, then only we will be able to take our course number A, right? So you have to remember this, that the linking will be from B to A, right? So now if I just try to draw the graph from the prerequisites, then you can clearly see that if I consider this particular prerequisite, so in order to take the course number 1, firstly I have to complete the course number 0, right? So if I want to take this course number 1, then firstly I have to complete the course number 0, right? So the linkage will be from 0 to 1. Why 0 to 1? Because firstly I need to complete course number 0, then only I will be able to take course number 1, right? And here the link is from B to A. Okay, from here prerequisite, you can clearly see that this 1 is nothing but A and this 0 is nothing but B. Okay, so I hope it is clear to you. Now if we consider this particular prerequisite, then it says that if you want to take the course number 2, then firstly you have to complete the course number 1. So again the link will be from B to A or from 1 to 2. If I want to take the course number 2, then firstly I have to complete course 1. Okay, therefore the link will be 1 to 2, right? Similarly, if I consider this particular prerequisite, then it says that if you want to take the course number 3, firstly you have to complete the course number 2. So the link will be from 2 to 3. Okay, if I want to take the course number 3, firstly it is important for me to complete the course number 2. Therefore this will be my link. Okay, so I hope this is clear to you. Now whenever we use topological sort along with BFS, then we use the concept of in degree. Now if you don't know what is in degree, let me just explain you. So let's say that we are having a node, and for this particular node, if we want to compute the in degree, then in degree is nothing but the number of incoming edges. Let's say we have 2 incoming edges, right, for this particular node, then the in degree of this node n will be equal to 2, right? Similarly, if we are having 3 incoming edges at this particular node, then the in degree for this particular node will be equal to 3, right? So we will have an in degree array or n vector where we will store the in degree for each and every node, right? Now if I ask you how many number of nodes do we have, you will say 1, 2, 3 and 4. So in total we have 4 number of nodes, and this 4 is nothing but the number of courses, right? So the size of this in degree array will also be equal to 4, right? It will be equal to 4, and this will be our index 0, 1, 2 and 3. And these indexes are representing each and every node, right? So this 0 represents the node 0, this 1 represents the node 1, this 2 represents the node 2 and so on, right? So now what we will do, we will compute the in degree for each and every node and we will store it inside our in degree array. So for this particular node number 0, if I ask you what are the number of incoming edges, then you can clearly see we do not have any incoming edge. If we do not have any incoming edge, then the in degree for this node 0 will be equal to 0, right? So at index number 0, I will write 0. Okay, I hope this is clear to you. Now for this particular node number 1, how many incoming edges you can see? So there is only one incoming edge from 0 to 1, right? So there is only one incoming edge. Therefore, this node number 1, the in degree will be equal to 1, right? So at the index 1, inside my in degree array, I will write 1. For this particular node number 2, again, if I ask you what will be the in degree or how many incoming edges you can see, you will say that we have only one incoming edge. Therefore, for this node number 2 as well, the in degree will be equal to 1. So here at the index number 2, I will write 1. Similarly, for this node number 3, if I again try to count the number of incoming edges, you can clearly see that we have just one incoming edge. Therefore, the in degree for this node number 3 will also be equal to 1. So at the index number 3 inside my in degree, I will write 1. Okay. Apart from this in degree array, we will also have one array named as topo sort. Okay, you can name it anything else as well. But what this topological sort or this array will have is, it will have the order of courses. Okay, so we can have more than one order to complete any course. Okay, for this particular course, the order is from 0, 1, 2 and 3. So this is the specific order in which we have to complete this course, right? So for some examples, we can have more than one courses. For some example, we can have only one course. So this topological sort array or topo sort array will have any one possible order. Okay, and at the end, we will compare that this topological sort array size is equal to 4 or not. Okay, if size of the topological sort array is equal to 4, it means that there was not cycle present and we will successfully be able to complete all the courses. We will also be using a queue data structure to store our nodes. So after computing the in degree, what we will do, we will linearly traverse into our in degree array and we will see that if any node have in degree equal to 0, then we will put that node inside our queue, correct? So here you can clearly see that we have only node 0 which is having a in degree equal to 0. So what we will do, we will put this 0 inside our queue, right? So we'll put this node number 0 inside our queue, correct? And now what we will do, we will run a while loop until my queue is not empty. Okay, so here you can clearly see that the queue is not empty, right? So now what I'll do, I will take out this 0 from my queue. Okay, I will take it out from my queue, and now I will add this 0 inside my topo sort array. Okay, so here I will write 0. Now why I am adding this 0 inside my topo sort array? Because the in degree for this particular 0 node is 0, right? In degree is equal to 0. It means that for this particular node we do not have any prerequisite. If we do not have any prerequisite for this node number 0, for this course number 0, it means that I can complete course 0 at first, right? I do not have to complete any other course in order to take course 0. So this course 0 will be the first course which I will complete. Okay, I hope this is clear to you, right? So after doing this, after adding 0 inside my topo sort array, the next step which I will do is I will just remove, I will erase all the outgoing edges from this node 0. Okay, so here you can clearly see that we have just one outgoing edge, just one outgoing edge. So now what I'll do, I'll just remove this outgoing edge, right? I will remove this outgoing edge. Okay, so now at this particular node number 1, I will check what is the in degree. So previously the in degree was equal to 1, but when I removed this particular outgoing edge from 0, now the in degree is equal to 0, right? Now the in degree is equal to 0. So what I'll do, I will just decrement the in degree, and now the in degree will become 0, right? Again I will check at this particular node, is the in degree for this particular node is 0 or not? I can clearly see that yes, the in degree is 0. If the in degree is 0, I will put this particular node inside my queue. So inside my queue, I will write 1, right? This is the node. Okay. So after completing this step, the next step will be, I will check, is my queue is empty or not? You can clearly see that no, my queue is not empty. So I will take the node which is present inside my queue. So inside my queue, the node present is 1. Okay. So now what I'll do, I will put this node inside my topo sort array. Okay. So here I will write 1. Why I am adding it inside my topo sort? Because I have already completed the course 0. So now I can surely complete this course 1, right? I can surely take this course 1. Therefore, I will add it inside my topo sort. So now what I'll do, again, I will do the same step. I will remove all the outgoing edges from the node 1. So there is only one outgoing edge, right? And it is going to 2. So what I'll do, I'll just remove it. Okay. So when I removed the outgoing edge to 2, what I'll do is I will again check. Now what is the updated in degree at the node 2? So the updated in degree is nothing but 0. It is 0, right? Because previously we had one incoming edge, but now as we have removed this at 2, we do not have any incoming edge. Therefore, the in degree for this particular node will get updated, and now the in degree will be equal to 0. Correct? Now I will check. What is the in degree? For this particular node? So the in degree is equal to 0. If the in degree is equal to 0, I will put it inside my queue. So inside my queue, I will put this node number 2. Okay, right. So now I will again check, is my queue is empty or not? You can clearly see that no, my queue is not empty. I have this 2. Okay, I have already taken out this one. So just ignore this. So inside my queue, I have this node number 2. Okay. So now what I'll do, I will take out this node 2, right? I will take out this node 2 from my queue, right? So now I will take out this node number 2. Now, the very first step will be, I will put it inside my topo sort, right? I will put it inside my topo sort array. So here I will write 0. Why I am writing 0 inside my topo sort? Because I have already completed course number 0. I have already completed course number 1. So now I can surely take course number 2. Okay. So I hope you are getting this. So now when I'm standing at the node number 2, the very first step will be, I will just remove all the outgoing edges from the node 2, right? So here from the node 2, we have only one outgoing edge from 2 to 3. So what we will do, we will just remove it, right? We will just remove it. After removing the outgoing edge from node 2 to node 3, at the node 3, I will check how many incoming edges I have. So previously I had one incoming edge, but as I have removed this, so the number of incoming edges or the in degree for this particular node 3 became 0, is now 0. So I will update my in degree. I will update inside my in degree array. Okay. So now again I will check, is the in degree for this particular node is equal to 0 or not. You can clearly see that yes, the in degree is 0. If the in degree is 0, I will put this node inside my queue. So now inside my queue, I will have 3. Okay. So again, I will check, is my queue is empty or not. You can clearly see, no, my queue is not empty. I have one node which is equal to 3, right? So I will take it out from my queue. Now the first step will be, I will put it inside my topo sort, right? I will put it inside my topo sort. So inside my topo sort, I will write 3, right? Why I am writing this 3? Because I have already completed the course 0. I have already completed the course 1. And I have also completed the course number 2. So now I can take this course number 3. Okay. Now when I'm standing here at this node number 3, I will remove all the outgoing edges from the node 3 to the other nodes. So here we do not have any outgoing edge. Okay. So we'll not do anything, right? We do not have any outgoing edge. So we'll not do anything, right? After doing this, we will again come back to our queue, and inside my queue, I will check, do I have any node or not? So here you can clearly see that I don't have any node because all the nodes have been taken out. So now my queue is empty. So when my queue will be empty, this algorithm will get stopped. Okay. And now we will check this particular topological sort array, right? So inside this topological sort, this is what we have. Okay. This is what we have. So this is nothing but it is the order of courses. Okay. Firstly, I have to complete course 0. Then I will complete course 1. After completing this course 1, I'll complete this course 2. After completing this course 2, I'll complete this course 3. Okay. So at the end, we just have to check what is the size of this particular array. You can clearly see that the size of this particular array is equal to 4, right? It means that I am able to complete 4 courses, right? I am able to complete 4 courses. So now I will compare this 4 with the equal to num courses, right? Num courses. What is this num courses? This num courses is nothing but the number of courses given to us, right? So the number of courses given to us was also equal to 4. So I will check that the size of the topological sort array and the number of courses are same or not. If they both are same, it means that we have successfully completed all the courses, right? So if they are equal, we will return true. If they are not equal, we will return false. So I hope this particular approach is clear to you. Now let's go to LeetCode and fastly code the approach which we have just discussed, and then we will discuss the time and space complexity. So what do we need? At very first, we need to create the graph. Okay. So for creating the graph, we can use adjacency matrix or adjacency list. I will be using an adjacency matrix. Okay. So therefore, I will write a vector of int, and I will name it as adj. Okay. And the size of this adj will be equal to the number of nodes, or you can say that the number of courses. Okay. So now I will run a loop for auto it belongs to the prerequisites. Okay. And here we will get our a and b. Okay. So a will be nothing but it of 0, and int b will be nothing but it of 1. Okay. So we have to create a link from b to a. Okay. Therefore, I will write adj of b dot push back a. Okay. So we are creating a link from b to a. Apart from this, what do we need? We also need one in degree vector or in degree array. Okay. So therefore here I will write vector of int in degree, and here also the size will be equal to the number of courses, and initially it will have 0 value. Okay. So inside this in degree array, initially we have 0. Okay. So we know that we have to count the number of incoming edges, right? So if there is an edge from b to a, right? If we are having an edge from b to a, then there is an incoming edge for a. Okay. There is an incoming edge for a. And inside this in degree, we just have to count those incoming edges. Okay. So here what we'll write, here we will write in degree of a plus plus. Okay. So we are just increasing the in degree of a, because if there is a link from b to a, right? So from b, there is an outgoing edge, and at A there is an incoming edge. Okay, so we have to count the incoming edges. Therefore, in degree of A will get incremented. Apart from this, we also need one array to store our ordering. Okay, so here I can just have one topo sort vector, and here inside this topo sort vector we will store the ordering. Okay, apart from this, what do we need? Apart from this, we need one q data structure. Okay, so we'll have q u e u e q of int, and let me just name it as q. Okay, so now what I need to do, I need to do a traversal into my int degree, and all the nodes which have int degree equal to 0, I will put it inside my queue. Okay, so here I will write for int I is equal to 0. I is lesser than the number of courses, so I is lesser than the number of courses, and I plus plus. Okay, so here I just need to write, I need to check that if in degree of the ith node is equal to 0, then I will just push it inside my queue. Okay, so I hope this is clear to you. After doing this, what do we need? We just need to run a while loop until my queue is not empty. So I will write a while loop until my queue is not empty. So what is the first step? The first step is to take out the node which is present inside my queue. Okay, so here I will write int node is equal to queue dot front. Okay, after that what we will do, we will just remove it from our queue, right? So for that, here I will write queue dot pop. Okay, after doing this, the first step is to put this node inside my topo sort array. Okay, so here I will write topo sort dot push back this node. Okay, now after this, what do we need? We need to go to all the outgoing edges, and we have to remove that outgoing edges. Okay, so for that, what we'll do here, we will write for auto neighbor of adj of this particular node. Okay, so what this for loop will do, this for loop will go at every neighbor of this particular node, right? It will go at every neighbor of the particular node, and there we have to remove the incoming edge, right? So for that, what we can do, we can just simply write in degree of neighbor minus minus. Okay, so if we are removing the outgoing edge, right, then all the neighbors will have one lesser in degree. Okay, so therefore we will decrease the in degree for each and every neighbor. Okay, after that we will check that if the in degree for any neighbor, the spelling of neighbor is wrong, so it will be NEIGHBOUR, right? So if the in degree for any neighbor is equal to 0, then we will just push that particular node, or you can say the particular neighbor, inside my queue. Okay, and this is going to be our code, and at the end I just have to check. So here I will write a return statement, and here I will write if the topo sort dot size is equal to not neighbor, it will be equal to num courses, right? If it is equal to num courses, then you will return true, and if it is not equal to the num courses, you will return false. So this is our code. I hope it is clear to you. Let me run this. So here you can clearly see that all the two sample test cases are running fine. Let me submit this. Here you can clearly see that this particular code is accepted. So I hope you have understood the algorithm and it's working. Now let's fastly discuss the time and space complexity. So firstly, let's talk about the space complexity. So we were using one ADJ matrix to make our graph, and the size of this ADJ matrix will be nothing but the size of our prerequisites, which is equal to P. If we talk about this in degree, topo sort, and queue data structure, so we were using all these three just to store the nodes, and if the total number of nodes are equal to n, then the space complexity will be O of n, O of n, and O of n for each. So the overall space complexity will be O of P plus O of n. Now if we talk about the time complexity, then we were using one for loop on our prerequisite matrix to make our graph, and if the size of this prerequisite is equal to P, then this for loop will consume O of P time complexity. We were also using one for loop on our in degree array, and if the size of this in degree array is equal to n, so this for loop will also consume O of n time complexity. And at the end, we were running this while loop on our queue while it is not empty. So the size of our queue can be equal to O of n at max. So this while loop will consume O of n time complexity. Inside this while loop, we were running a for loop, and this for loop is running on all the edges, right? And the total number of edges are nothing but the size of our prerequisite matrix, which is equal to O of P. So this while loop and for loop will together take O of n plus P time complexity. So now if I try to write the simplified time complexity, then it will be equal to O of P plus N. So I hope this video was helpful to you. You have understood the algorithm. If it was, then make sure that you like to this video. Make sure that you drop a comment, and don't forget to subscribe to this channel so that you will get this type of content regularly. We will meet again tomorrow with a new question.